Hi and welcome to DCO. My name is David Capetti, and in this video I'll be sharing with you how to create this building. It's a full tutorial where I share with you a bunch of techniques and exercises to achieve this design. We start with base geometry, which is a U shape that is then offset to create the base geometry. Once we have that base geometry, then we can subdivide the columns and then create a beam system that then we array vertically, and then at the end we create a facade to enclose the entire inside space. This is a full-length tutorial that I created that I am sharing all of the steps. This is a very practical design that can be useful for anyone that is fairly new and wants to see how you can use this program. It is a little bit of a longer one, so if you do achieve it or if you do have any other questions, make sure to let me know. I have resources on my website, and I post videos like these every week where I share with you how to create parametric designs like these and that are practical and that you can use in everyday life. With that being said, thank you very much for being here. If you have any questions, let me know. Check out some more resources if this is what you're into, and let's get started. The first thing we'll do is construct a point, which we will use to move around. So we'll go here to the brand new Grasshopper file. I'll double click and go to construct point. This construct point is important because it creates a parametric point, which, as you can see, I can't select it here inside of the Rhino viewport. So we'll be using this parametric point. I like to route it through an empty point component because this will let me move and change the location later on. Now that we have this point we will move around to create a U shape. So first thing, we'll go to move. We'll take this point and move it in the Y direction. The units we're working with are feet. So if I said 15 with this slider, that would be 15 feet. This would be 100 feet. So now we can take this point that we have moved this way and move it over to the right. So to move it to the right, I like to guide myself using this XYZ coordinate system. So we'll be going positive X. We'll take this, copy it by sliding it and tapping Alt. Now we can plug that geometry output into the move input. Now we can move this in the X direction. I'll copy the other slider. So now we have this point. The next thing we can do is either take this point and move it this way, or take this point and move it negative Y. So there are two avenues of doing this. I think it's easier if we use this original point as the move input, and then we'll use this X to move it to the right. So now we can label these as our points. This is going to be grouped, then I'll call this 1. Group, call this 2. This is the third one, so I'll Control G to group. Then use this, Control G to group it, and also give it a label. Now the color is blue because I have my default color as blue, but you can always change it to whatever color you want. The reason why I have these labels is it will make it easier for us to see which points we want to connect together. Next, we'll be connecting those using a polyline. So this is under the category of moving points to create geometry. So let's go here into a polyline component. We'll be using all of these points, starting with the 1 and holding down Shift to add additional inputs. As you can see, we've created this polyline that can be updated using these sliders. So we can always change the form of our base building. And this would be a courtyard area that would be on the inside. So we can take this polyline and offset it. The will offset here by default to the outside, so we can use a different slider. Move this over, tap Alt. Now, of course, we can always change the names of these sliders. So we can right click on it and call this size. We'll just call this X. And this is actually Y. We'll do Y. This is going to be X for the X size. And then here, the distance is going to be the building size. So we'll just call this offset building. Great. So with these two, now we can put them together. How do we put them together? Well, we can either loft it together, and that will create a plane between the two. So this and this. Or the other way is getting the endpoints, and we technically already have the endpoints of these, so we can use these points, 1 and 4, to connect to the endpoints of this offset. Or we could also get the endpoints of this polyline. Either way works, so let me show you that. We'll go to endpoints, which means that it will give us the start and end point of this polyline, which we can connect, like I said, using a line segment starting at a point and ending at a different point. So we'll go to the first. Then here, this will actually be the start point. So we created that line segment. We can do that again with the end point and the fourth point. So you're able to see the 1, 2, 3, 4, and so 4, you can hold down, not necessarily shift because we don't need it. We're only doing one input. So we have two line segments that we have here. We can join those together using join curve. We'll start with this line, move on to this one, then plug in the other two original polylines, holding down shift this time, so we can add more than one input. When we hover over the output, you'll see we have two locally defined values, which means that it's giving us an error because we want this to be one polyline. So this is where we would right click here and go to flatten. And the reason we flatten is so it all comes in as one long list and it joins it all together. And the reason we know that it works is when we hover over the curves output and we see polyline curve. So with this, we can hide everything else. And this would be our base geometry. Now, I will group some of these sliders so we can see how it all was put together. And if you want to organize your geometry that you're creating by modules, what I mean is if you want to just take this bottom plane and have it be shown here or organized, I can group here. I can do Control G to group. And so this can be called base geometry. This is going to be the resulting polyline that we can change the size here. And if you don't like the color, like I said, we can change the color here to be something else. And then you can also go here to make color defaults, and that will always give it that color. Now with this, we're going to move on to creating the base form for the building. So the next thing we'll do is we'll take this curve and we'll turn it into a surface. So we'll go to planar surface. I think that's what it's called. So planar surface or boundary surface. They are different inside of Rhino and Grasshopper. So just know that boundary surface will create a surface outside within the boundaries of the polyline. And this is what we'll be using to create our structural system. So first thing we'll do is we'll take this and we'll bring in an area component. This will give us the centroid of this object. What is the centroid? It's the mathematical center of the overall geometry of this shape. It will change depending on how big this form is, but it's the overall center of it. The reason why we extract this is to, when we create contours, what happens is we need a point where it starts from. So when I create contours, I'll go here to contour. The contour component, it's going to have some inputs. The shape is going to be what the contours will go through. The point is going to be where it starts from. And the direction is going to be either, we can use a vector, we can use other methods, but for this one, we'll go in both in the Y and in the X direction, because we want subdivisions this way and this way for our structural system. So we'll go here to direction in the Y direction, and the distance, we'll say 15.5. So that's 15.5 feet. And so this is the spacing of our structural system. So if we said 25 between each beam, that's what we can do. We'll do this exact same thing. So we'll take this, tap Alt, and copy it. Notice that I didn't copy the slider. The reason why is because if you want the spacing to be the same, you would keep that slider. But if you want it to be different, then that's something that we can change. We'll change the direction, and we'll see here that now we have this grid system that we've created overlaid on that surface, and this will help us create our structure. So with these two being put together, now we want to get the points in which they overlap. The way to do this is go to the intersect tab, physical, and then we have brep and curve. So we can plug in our surface as our brep, and contours, or actually, it's going to be a little bit different. We're going to go multiple curves because we'll be using where this set of curves intersects with this set of curves, and we'll flatten the input, and this will give us the points where they overlap. The output, we have 45. So let's see here. 9, and then we have 9. Here is the way to check this. So we'll go to bake. There's a command in Rhino, so we'll take this, middle click and bake. And there's one per bay. Okay, we'll take these points and go to call duplicates, which will make sure that we don't have any duplicates. So let's flatten here. So 45 means that that's how many points we have here. So that's how many columns you would have inside of your design. All right, next we'll take these points. And since we see that it actually did not remove any duplicates because there are no overlapping points or overlapping geometry, so we can technically get rid of this and just use these points. I will route it through this point component so I can kind of see that this is where those would be, and we can always change the spacing. Okay. At these points, we're going to create the columns. So we'll go to rectangle. If you want the columns not to be symmetrical, we're going to pick a different size for X and Y. So we'll go here to 2.5. Notice that they're not centered. So what we'll do is we'll move these rectangles in this particular direction. I'll go vector x, y, z. And I know that this 3.1 goes in the x. We'll plug that into the x here. We'll plug this into the y. Now, when we plug this vector into the motion, it's moving it to that corner. So notice that it's the wrong direction. We have to go negative. And we actually have to divide by 2. So this puts it in the other corner. And if we do negative, we do divide by 2 right before that. So /2. Now we can plug this into the A. It's going to give us 2, which means that it's going to do half of it. Then we can plug this in. Now we've moved it simply by moving it back halfway. This the exact amount that the column is, so we can always change the size. Now notice that this one's still being previewed, so it's overlapping with our geometry. But now we have the ability to change the size of our columns. And with this, we need to create our surfaces so we can extrude these as solids. Now, notice that we've created this entire set of stuff here, which is going to be the structure. So technically, we should group this together, but we'll do that right after we extrude this out. So we'll have this geometry that was moved to the center, then we'll go to boundary surfaces. Next, we'll extrude. In which direction? We'll up in the Z direction, so we can move it up. And we'll give it a specific value of 12.5. Max, I'll go here to 20. We don't get too crazy here. We'll go here to 13. All right, this is looking great. We have the overall size that we can change. This will also limit how many bays we have. So this is the power of parametric design, is that we can change the design. We can see where things intersect, and we can also move. So this is the centroid where the center is created. If this, let's say, was not the right location, you wanted to shift it over to the right because there's more space here, and these are kind of all the way to the edge. Well, technically, we could do this. Let's move this out. And this is the power of parametric design, where we can come back to our points in geometry and move it if we have slight adjustments we want to create. But we can also keep all of our work organized here, and we can see exactly how this was created. So we'll take this centroid, we'll move this. In which direction? Well, we can move it in the negative y or positive y. So this is what we'll do. We'll bring in a y vector. Do that again. Unit y. Plug this into the motion. Now we're going to plug in a factor. What does the factor need to be? Well, a positive and a negative, so we can move it in either direction. So we'll go here to -20 less than 0 less than 20. What is this going to do? It's going to create a custom slider at -20 to 20 and set it at 0. So if you think about it, we haven't done anything, right? We moved it by 0. But if at some point, or if at the end, you see, I want to create this spacing, but I need to shift it, well, this would be under the category of shifting the reference point, so you can adjust where that is located. We can also find the center point of this one, center point of this line, create a line segment, find the midpoints, and use that as our geometry if the most important part is to maintain this area being symmetrical. So just keep that in mind. This is how parametric design works. So you can always come back and add more details. For the most part, I try to create straightforward tutorials or practical tutorials that you don't necessarily have to come back and tweak things, but with this tutorial, I wanted to take the time and show you all of the methods and techniques that you can use to create these parametric designs. Now, the thing that is interesting about this particular design is called bilateral symmetry, which means that it's only two sides that are symmetrical. These other two sides are not. So the symmetry needs to be maintained through the center of the U rather than through the center of this area. Okay, with that, let's move on. So let's call this, let's label this. This is going to be column height. I'll group it so it gives it a color, and then same thing here. This is going to be column size X. I can also right click, copy this. So Control A to select everything, Control C to copy. Then same thing here, Control A to select everything, Control V to paste. And then we can just go to size Y, save a little bit of time by just copying the information of the other slider. Let's do these individually. These are going to be points. These are going to be column base point. Contours are important, so I'll group those. We're just keeping our information more than anything organized here. If you see a bunch of outputs out of one and you want to move it and you see that it's moving everything and you just want to keep it there, double click, creates a relay. You can move it back, maintaining this in the same general area, and then we'll move this down to Control G and know that this is going to be our base geometry, base surface geometry. Going to be shift column locations. These don't need an input because these are just giving the directions as to where those are created. And if you wanted to create a completely different direction, you could. It's just, this is the more typical way that you'd see a structural system develop. You see center lines and then columns that sit on those center lines. Take this, disable preview, because we have all of these points being shown. And at this point, now we're going to be creating the beam system. So for that, we're going to go back to our contours. And we're going to move them in the Z direction. So one, we'll do one, and we'll do the other as separate components so we don't join them all into one place. And then we're going to move them up by the same amount as the column height. So we can have them sitting on top, and disable the preview on the originals because they are now old. So with this, we have a beam system that cantilevers at the outside. So we can go here to these, and we'll go to extrude for the beam heights. That's what it is. So we'll take this base input, those lines, and we'll do the same thing for this. Now we're going to extrude in the Z direction. So up, and then we'll go to 3.50. So with this, we're able to change the height of our columns. or of our beams. So we're going to disable the preview here. Now at this point, you're wondering, how can we turn it into a solid? Now here's the cool thing. They're centered, which means that what we're going to do is move every one of these planes perpendicular to the surface and extrude it by twice the amount so it's centered. Now here is the interesting part, is that in the X and Y, they are going to be different because we have 2 and 2 here, but let's change this to 2 and 4. So we're able to see in which way we need to extrude more. And that is determined by the column size. So it's going to be half of the column size is going to be moved one way, and then it's extruded by the exact column size. Without talking too much, let me just show you that we can do that individually to each one. So we're going to move this extrusion in the Y direction. So we can go negative Y, or we could just go Y. Either way works. We'll go to negative Y direction, but that's going to be this. So this divided by 2, column size divided by 2, then this is going to be moved in the negative direction. But before that, we need to go in the Y direction. Oh, actually, never mind. No, it does have to, because there's no vector here. So we need to tell it 4 divided by 2 equals 2. In the Y direction, negative. I'll take this, plug that into the motion. And notice that it lines up right to here because it's halfway to the outside. Now we'll do extrude. In the Y direction, but not negative, by the full amount in the Y direction. And this will be plugged into the extrusion direction. We can disable the preview on both of these and see that when we tie it to our numbers, they will maintain consistency. We'll go to 4 and do the exact same thing in the other direction. Why do I think this is good? Because it gives you the opportunity to practice it multiple times in different areas. So we already know how to do this. Let's do it again from the beginning. So this, we're going to move it. Because technically we can copy some of these, but we have to change the vector. So we'll do it again as a kind of reinforcement. So we'll take this extrusion, go to the move component. We're going to go to the Y divided by 2 because it's halfway. Then we're going to go in which direction? Well, this is going to go in the X direction. Okay, X direction. Then halfway in the X direction and negative. So we keep it consistent as we did in the last one. Most of this stuff is the same as this. You can see here, okay, negative motion. Now disable the preview on the original. Next part is going to be to take this and extrude it. So extrude. Which direction? Well, we know 2 in the x by the full amount, not by half. And this will go into our direction. Now let's go back this and disable preview. And so we have overlapping geometry, but these are going to be beams. And so for this, we'll use union. Solid union between these solids and these solids. Right click and flatten the input. This way we ensure that we have one closed unioned object that is a closed B-rep. We can disable the preview on our original. And then if you see creases here that you don't want, this is where we can go to merge all coplanar faces and flatten the input. What does that do? Well, by using merge all coplanar faces, we gotten rid of the creases that sometimes are left over when you do Boolean union. So with this, I feel like we need more in this direction. Well, let's go back. Bring it to 35 is both in these directions. So we're going to change the spacing on the x. X is the bottom one. Notice that we can have different beam sizes depending on which direction. So those are the cool things that we can do with this particular script. Now we're going to be taking this up to the floor and creating the floor above, because this is already our base geometry for a ground plane. Now we're going to be creating one right up here to create a floor slab. All right, so now that we have gotten to this point, I'll take this and put that into a B-rep or geometry empty component so we can see that this is going to be our columns. I'll group this. All of these are beams, beam system, and this is going to be our column system. So I'll go here to B-rep, which means boundary representation, and it'll be this geometry. Group it, bring this out, possibly just out to here, so we have the beam system in our columns organized. Now this is something that at the end we can create a cluster with everything organized. For now, as we make progress in the script, it's just best to keep things organized like this to be able to come back and use some of this geometry again for other portions of your design. Let's go back to our surface. Base surface, move, create the floor plate. In which direction? So we'll take this in the Z direction. But the Z direction is made up of two different values. Number one is going to be height of column. Number two, height of beam. So we use mathematical addition to bring back beam size plus the column height. You do not, I guess you could add up the vectors. Sometimes I just use the numbers to plug them in as an addition, then use a new vector here, and it will move it right up to it. Why? Because we need to be aware that when we create or when we move something, we need to move it using the sliders that we already have, which means that we already have this slider, we already have this slider. So we technically don't need to even a slider to move the base plate up to the top. And so here, there are different things that we can do. Number one, we can take this we can offset it. So if we use a curve component, you can extract the outside lines of that design. When I hover over the output, it says 1 polyline curve. I'll disable the preview on all of this, and you'll see that what I'm going to do now is take this and offset it. This is going to be an overhang from our columns. And I'll just create a new slider to create an overhang here. This way we can disable preview and see that our beams don't necessarily have to go all the way to the end. They can end here. This can be a little bit of a cantilever portion. Also, we can cut away portions of this design. So with this, we'll go to Boundary Surfaces. And extrude in the Z direction. By how much? We'll say 1.5 since we're using feet. This would be 1.5 feet. Great. This will be our design for the most part. Now what we can do is create the floor slab. So we'll go back to our surface, and here's the trick for this one. The ground slab is always going to be a little bit higher than the outside. So this is why I can extrude this down. Just that the extrusion amount is going to be in the negative direction of this. So this is going to be floor slab thickness. And then here we'll go negative because we want it to go down. Now this area doesn't have the overhang, and the reason for that is because I am going to take this, it's a curve component, to extract the outside line. I'll take this back out here, and I'll offset it again by using the same as I did up here. So we'll copy this, tap Alt, great. We have these two lines here. To create a surface between those two, we'll go to Boundary Surfaces. Plug both in. Make sure to flatten the input so it only creates, let's see here. Oh, sorry, I reversed it. It's actually flattened and no reverse. So now we have this outside surface. We're going to move it down. So if this is 1.5, we'll create a new slider. Copy this vector, and we'll be moving. So we'll be moving this down. So negative direction with a Z vector, and we'll move this surface down by that amount. So 0.5 is going to be 6 inches. Now I can extrude down by just copying this. So we're going to copy the extrusion of that one and just plug in our other surface as the input. The reason why is here, this would be a sidewalk that goes around, but here at the top, it's just an overhang that could technically be a cover for the surrounding walkway. So for now, we'll leave it like this. Disable the preview on everything else. going to be a brep. And we'll do the same thing for this. Floor slab, and then so disable the preview on everything except for this. So floor slab 2. Then we'll do floor slab 1 and then floor slab here. So we'll go to floor slab 1 and then here sidewalk or walkway. Slab thickness, this is going to be overhang. Grouping this together. It's going to be our size. All right, so we've created this so far. Now we need to create basically the upper floors. But with that being said, go ahead and save this so we can make more progress. Sometimes it's best to do it that way. You don't want to lose your work. All right, let's move on to the next portion now. We can always come back and organize this a little bit more. For now, I'll group this entire portion. This is going to make sure that I have my information organized. Everything that's done in this portion is mostly going to be all of this work, and basically the entire script is taken care of here on the end portion. But the next parts are not necessarily going to be for creating this. It's going to be for creating an array of the building above. We'll go to move. We will move the columns, which will be back here. Once we do one of these, then we have the stage set to do it to others. When we move this, it's going to by default move it by 10, but this is where we bring in the series component because we need to move it up depending on how many times we want to copy it. So we'll go to move. The motion is going to be in the Z direction. And what series does is it creates a series of numbers that you can control how many output you can create. So let me explain that again. By default, this series numbers create 10 numbers, starting at 0, stepping by 1, and creating 10 points. So it will create a 0 to 9 list of points that we can plug into the motion. But notice that what's happened is we've just created, let's go here to graft. That's what we need to do, is graft it so it does it to all of them. What happens is it's created 10 copies of the array step by 1. So if I step by 5, we can see that we're increasing the spacing, but we can also fix the count. If we only want 3 floors, we want 3 numbers starting at 0, stepping by the column height. So however tall this is going to be column height plus beam height, and we already have these two values added. We have them added here, and we have this Z vector. So we can use this number, plug it into the step, and create 3 sets of those columns. We can add more above. For now, we'll keep it at 2. So we just create a copy right above. And the reason why we need to also add another numbers because now we have the floor slab. So this is where we take this addition and we do another addition. So we'll go to plus and we'll do 16.75 plus slab thickness 1.5, which means that it's going to go 18.25, and that is going to be the value you want to use for the step. The step is going to be the same. Next, we're going to be, rather than, so we'll go here to a brep so we can keep it consistent, and these would be grouped and labeled columns. Column array. Disable the preview on the original, and now do the same thing with floor slab. We'll do this again, but this time, rather than a floor slab, we're going to be using the beam system. Now we have overlapping geometry, so we don't need most of this stuff here, except for the ground slab. So that's I'll ungroup that one because that's no longer, well, yeah, that's actually an important one to kind of keep in mind here. Save the preview and notice that with just this slider, we can add more floors. So this structural system creates a floor plate, subdivided columns, beam system, and floor slab. Now, I'm trying to show you here also other aspects that may be important, like lateral support, creating certain points in which these two columns might create a wall in between. This gives it lateral stability for the overall design. But with this base geometry, now we can move on to creating the outside facade of our structure here. Because now, let's go back to the beginning and see that all of this is able to be updated and changed using just these initial sliders to change your overall design here. So if you want a small courtyard, that's something that we can adjust. If you want the courtyard to be a little bit larger, but maybe the overall building size not to be as long, this is something we can adjust. So it's always good to go back to the original to see if most of this information we have the ability to change and have it not mess up the entire design. So with this being said, let's move on to the facade portion, which, let me change this first, number of floors. The facade can be developed in so many different ways that I'm going to show you one technique, but this is a portion in which we can spend a lot of time figuring out or doing some research as to what are different systems that we can apply, and we can create them fully parametrically. This particular example is going to be very practical. It's not going to have too many details, but let's get into how we would develop the facade for something like this. So I was looking at this a little bit closer, and there's a change I want to make. I no longer want to have the walkway, so I'm going to delete this and delete this and just go back to the part where I have the floor slab here, offset it to the outside, which is fine, but no longer need that input, because then we can use this slab. This slab then we can use to extrude. So floor slab 1, this is going to be this geometry. I'll disable the preview now. We have the floor slab being the same as the ones above. The reason why I changed my mind is because this will help us on the portion where we're going to be creating the facade, because we're going to be offsetting this to the outside and creating a location here where it intersects or where it lines up with our beam system. So what we'll do is we'll go back to where our beam system was created, which are all of these contours. I disabled it by accident. We'll go to preview. Now we'll take these two and where they intersect with this curve. What's that curve? That curve is our original line. So why is that important? Well, where those intersect, where these and these intersect, this is where I want to extract some points. So we'll go back to our intersect, physical, and multiple curves. And we'll have where these and these intersect. So actually, this may not be the best one. There's another one called physical, curve, and curve, which means these, where these curves, so curves A and B, flatten, so they're all in one list. Then where that intersects with this, hold down Shift. Now we have extracted the exact points that we can use for our exterior facade. Great, so we got these points here. Next portion, let's move this down because this is going to be, this is mostly structure here. Down here, we'll take care of the facade. So we'll take these points, we'll go to rectangle component, and we'll plug in a value. So we'll go 0.500, and we'll do the same thing in the X and Y. But notice that they're not centered again. So what happens is, in some instances, it'll be to the outside, some instances to the inside. This is why I move this. Once again, using vector XYZ, this is going to be X, this is going to be Y. We're going to go divide by 2. So I'm doing this one quick so you see my workflow. Divide by 2, and then negative. So now it's a centered rectangle. Now, here's a cool thing that we can do. If we do a curve component here, technically we can do something like this. We can create a cluster for this area, for this. This is where Grasshopper can become really powerful. You can create your own custom cluster. This is going to be this. And then we can relabel this cluster as rectangle. from center. Delete the plain input. So we see that now when you plug in these points, it will create a rectangle from the center, either in the X, Y direction. Showing you some extra tricks here now that this is a little bit of a longer format. You'll be able to see other workflow tricks that I use here. Okay, boundary surfaces. And extrude. The Z direction will go by 150 or 15. Now it does overlap with the floor slabs there, but the cool thing is that it's on the outside of the beam. So this is where it could be connected to the outside. So you have a very nice and strong connection. Here is the weird thing about this. Okay, to tie this to our sliders that we have already, we need to be conscious of how much space we need. I'll select this. I'll go to an elevation view, and this will help you visualize what we need to do. We need to do this. So column height plus beam plus floor slab times 3. So the spacing is going to be out here when we did all of this addition for 3 floors, 18.25 is the overall size. So we do this times multiplied by how many floors. Sometimes we already have this work done. We can always reroute those again to another mathematical addition and things like that, and it will work just fine. But sometimes you can be efficient in terms of reusing information you already have so you don't have to go back and recreate it. Number of floors, 3. So that's the multiplication. The original size for this gap is going to be 18.25 as it sits now. This result is going to be our height. So we'll take this, we'll bring this out here so we can see it all, and then plug in this number to the Z. Notice that we brought it all the way up here. Now, if you want it to be a little bit extra, you can subtract a floor slab number from this because it's going all the way to the top. So we can take this and do a subtraction and subtract the floor slab. So if here we have floor slab 2, this is the direction, and it's extruded by this much. Well, this is how much, not the vector, I'll use the number. We'll use this to subtract from the original number. And now when I plug this in, notice that it's brought down here. The cool thing about this, or what this allows us to do, is to just change this slider to create more floors, and the facade or storefront structure is going to be going all the way up to the top as well. Great. Now we have this, and it's centered. So we're going to be creating glass that goes from the floor to floor slab and array it up so we don't have to do a Boolean difference. That will be very taxing because we have too many, we just have too many floors and too much geometry to copy it. And for it to be efficient, it's a lot easier to just do them in chunks. So great. Okay, let's go back here. Now we're going to create an offset. offset curve from our original rectangle. So we're always kind of going back to our base geometry that we can use over and over again. So here is the interesting point. We're going to offset to the outside of this. So if our storefront is 6.9, or we'll just say 1 in this direction, well, we need to do 1 divided by 2 because we want to go halfway to the outside and we want it to be tied to the size of this. Divided by 2, and that's going to determine our offset, which is all the way back here. I'll hold and select and kind of scroll with my middle wheel, and we'll move this into the distance. Notice that it's now been tied to our storefront, which means that we can offset it again. So I'm just copying the offset. Now this is going to be the glass. So between this and this, it's going to be the glass. Our original, it's not as important because it would overlap with our storefront here. We want this to be full glass on the outside, even though these are on the inside. So we'll take those two and create a boundary surface between those two offsets, which means that they will overlap unless you flatten the input. Now we're going to extrude this not all the way up past this, but it's going to be column plus beam. And that's actually the same as the move here. So notice that this ground plane was moved up by this amount. And since that amount here has already been added between the column and the beam, and these are things that sometimes you want to kind of keep in your mind as you work on it. Sometimes it's hard to keep track if you're kind of fairly new and you're still trying to wrap your head around it. But over time, you'll be able to keep in mind all of the steps that you took so you can come back and not have to recreate them from the beginning, but use what you have. So this is going to be moved up in the Z direction like this, but this will be used as our extrusion. So here's what happened. We need to take this, go to extrude. Thing is, I hadn't set up the stage yet, so when I was dragging it over, I didn't have anything to plug it into. We'll plug it into the direction for our extrusion. We'll go back here and go to floor slab. It was extruded up, but it was first moved up here using these. And now, as we did with all of these, we will do with this last one. I'll disable the preview on all of this. This is going to be our facade portion. So glass structure, going to be glass structure. This is in the Y direction. This is in the X direction. Copying this one down so we can create one for the storefront. So this will be glass structure. Going to be glass. So Control G to group, and then we'll go here, glass. Glass depth. disable the preview on all of the things that are overlapping. So we can, at the end here, have so I'm moving the floor slab here, but it's part of the group. So just copying that one. It's a little bit redundant, but it's okay sometimes to do that. So we'll go here to ground plane. Ground slab. We'll just call it floor slab. Going back to all of those things that I don't need. And it's good to, towards the end, organize your information and have it be a little bit more clear to see for most people. I like to share these with people because a lot of people ask me, oh, can I get a hold of that? And so now I've created a few different ways to access these, either through the script vault or script store. Okay, let's move this up. Number of floors, just to make sure that we have everything working. So at this point, I am going to conclude the tutorial. Most of this stuff, most of the things that I went over here are going to be useful for many other scripts, not just this one. Just this particular design I was really looking forward to doing because I've created some of these before, but in this one I wanted to make sure that it's all tied together and it's all clear for you guys to follow along and ask me any questions if you have any. If you're fairly new to Grasshopper, I completely understand if you've kind of gotten lost, if you don't really understand how it all ties together. What I do suggest is give it time. Practice every day, practice different exercises, different techniques, or different tutorials, and over time you'll see how it is a completely different language and how you can learn this different language because it's still tied to some of the stuff that you did before, maybe inside of Rhino. But this gives you the power to always come back to your work, know how you created it, and therefore it will actually make you a way better designer. It'll make you a better 3D modeler, and it will actually strengthen your mental ability because you have to sometimes juggle multiple different aspects and information inside of a design rather than sometimes going in a linear fashion and not really understanding how you got there. Here you have all of your steps laid out from beginning to end, and you can see how they're connected, how they're tied together. And this is, in my opinion, the power of this program. It is the next level after 3D modeling. You don't necessarily have to go this far, but this will enlighten your brain and help you be able to see designs in a completely different way, and how parameters and how objects are created from the beginning. And so there are a lot of techniques, a lot of things that you could never do outside of Rhino, that you couldn't do outside of Grasshopper, that you can do here, like parallel processing. You can do multiple offsets and multiple things at the same time. Sometimes inside of Rhino, that gives you a little bit of an issue. So thank you very much for being here. Hopefully you found this useful. I want to do more of these long version tutorials, but what I would definitely love is if you guys wrote in the comments, or if you sent me a message letting me know, this is what I'm into and this is what I would like to see created parametrically, and I'll create a full-length tutorial for you guys. So thank you very much for being here. I'm truly happy that I'm able to help people in architecture with these advanced modeling tools, because I feel like architects and designers are getting a little bit lazy with all of the tools that we have nowadays that make it so easy for us to design, that sometimes when we see something that is difficult and time consuming, we go, oh, I don't need to do that. I already have an easier way of doing it. But that's not the point. The point is to become the best designer you can be, to be able to tackle any task that is handed to you, and to not be intimidated by design tools like these, because if anything, you can always learn them and hire someone to do them for you. So hopefully this little bit of end talk helps you and helps you visualize what this can be used for, and that if you gotten to this point and you created this tutorial, that you should be proud of yourself. This is not an easy tool to learn, and it is exciting that there are so many other things that we can do with it. I want to show you more practical tutorials. So thank you very much for being here. Like I said, I'm truly blessed to be able to help people like you guys online. And if you want more resources, I have more videos in the future that I post weekly. I also have a website where I put my resources. And if you have any questions or anything, just let me know. Thank you very much for being here, and I hope to see you on the next one.